Atlas 3A is the future of the company. It's the future of Lockheed Martin.
It's somewhat scary and exciting all at the same time.
I've been working on the Atlas family for 11 years.
I've been working with the Atlas program for 2 years now.
I've been working Atlas family since Atlas 1.
I've worked on the Atlas program since 1987.
To eliminate parts from the booster and the upper stage. All in all, we're saving about 15,000 parts compared to an Atlas II.
I've worked on Ac201 in the clean room.
My role on 201 actually is just a little bit of everything.
I did quite a bit of all of the propulsion work on that vehicle.
My job was mostly in the harness area, the electrical.
We've named this new series of launch vehicles the Atlas III.
When that first fire went off, I was so excited. And the next day, I just walked around with a smile on my face.
The Atlas III is about 10 foot bigger in length. That's why it required to modify the pad.
I started the program in San Diego in 1982, and the Atlas I program progressed through and lived with it, grown up with it.
We'll have 17,722 seconds of test time, over 107 tests, and over probably someone on the order of maybe 27 to 28 different engine builds.
On launch day, I will definitely be watching Ac201 launch.
I do have plane tickets already for that trip.
Absolutely be watching on launch day. I think it's exciting to be able to work on this project because of the integration between the American technology and Russian technology. I think it's exciting. I get to point at that and show my daughter and say, look, I helped build that. I helped put that in space.
This is kind of what I like to call the Ac201 Atlas 3A Run for the Roses.
And so it was kind of like a milestone in history.
We all know that in order to get to orbit, all it takes is 1,000 little miracles, all to work perfectly, all in the right sequence.
One thing we have to our advantage is that we're going from a more complicated vehicle to a simpler vehicle.
I have a 4-year-old son that says, my daddy builds rockets, and that's his job.
Go Atlas! Go Centaur!
I think it's very important to our company to move on to the next generation.
Every one of you are critical to the whole job of having a successful product.
But I also wanted to make a special thanks to all the family members, and that's what I like to call our silent hero, because they're the ones that give us the moral support to get us to where we are today.
This is an extremely important flight. They've done an absolutely phenomenal job, and I want to thank them and congratulate them for all of their hard work.
Ready to report to resume countdown. Atlas Systems propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Vehicle electrical. Go. Light termination system. Go. Propellant utilization. Go. Centaur Systems propulsion. Go. LO2. Go. LH2. Go. Vehicle electrical. Go. Light control. Go. CLS monitor. Go. Light termination system. Go. Telemetry. Go. RF. Go. Complex systems instrumentation. Go. Launch control. Go. Thermal control. Go. Boom. Go. Launcher. Go. Water. Go. Complex electrical. Go. Power monitor vehicle loads. Go. UV control. Go. Operations safety manager. Go. -45. Status check propellants. Go Atlas. Go Centaur. Go Centaur. Pneumatics. Go Atlas. Go Centaur.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, and the RD-180 engine roars to life and liftoff for the maiden flight of the Lockheed Martin Atlas III rocket with the W4 spacecraft on board for Eutelsat of Paris, France. With this Atlas flight underway, let's listen to Mr. Rob Hinn providing ascent data from the telemetry lab here at the Mission.
We have Atlas to you to close loop control. Engine operating parameters continue to look normal. And continue to look good. The vehicle is now throttling down in preparation for supersonic transition. It continues to fly normally. Everything looks good. Operating parameters continue to look normal. We're on JDMTA data. Data quality looks good. Clicking the throttle up post-transonics in 15 seconds. Everything continues to look normal. And we are throttling up. Vehicle rates look nice and smooth. Throttle up is complete. Everything looks good. And we're now passing through the region of maximum dynamic pressure. And rates are smoothing out as we're passing through transonics. And everything continues to look normal on the engine. Staying steady at 87% thrust. Next mark event we're looking for is firing the pyro valve to pressurize the reaction control system in 15 seconds. Engine parameters continue to look good. And we fire the pyro valve. The control system parameters are pressurizing. Turning in our next throttle segment, the constant 5.5 G hold throttle segment. And we have boost phase chill down starting. Housing temps are responding to the flow of fuel through the Centaur engines. Everything looks good. And continuing to show the throttle segment, everything looking good. We've throttled down in preparation for BECO. We have booster engine cutoff. Everything looks good there. We have stage separation. We have fuel pre-start.
We've had a nominal BECO.
We have LOX pre-start. Thanks. We have ignition. And full thrust, the Centaur main engine is up and running normally. Normal operating parameters on the Centaur main engine. Everything continues to look normal on this mission. And we have fairing separation right on time. Everything is looking absolutely normal on this mission so far.
This is Atlas Mission Control at L plus 3 minutes 53 seconds into the flight. Spectacular videos. We have had a nominal mission so far.
And Centaur propellant tank pressures look good. Engine operating parameters continue to look good. And helium storage bottle also looks good. And the vehicle continues right down the middle of the range track. Everything perfectly normal on this mission thus far. And we are now 332 seconds into the mission, the vehicle is 124 nautical miles in altitude, 464 nautical miles downrange at 10,400 miles per hour. And we do have our roll to Tidris. Everything's looking good thus far. And we continue to see normal thruster activity in the reaction control system. Engine continues to burn normally. SRP has gone to closed loop control. Center engine responding as expected to the change in mixture ratio. RCS activity continues to look good. Propellant tanks are stable and at the right levels. And rates continue to be right down the middle. For vehicle rates, everything looks good there. And we are steering through our dogleg maneuver. In the trajectory, everything looks good there.
This is Atlas Mission Control at mission elapsed time of 6 minutes, 49 seconds, counting.
And we are now on Antigua data. Everything continues to look good. And mark events look pretty close to nominal. Engine continues to operate normally. And coming up on MECO 1, acceleration profiles right where we expected. And we have a loss of data at this time. Blink on approximately 10 seconds to MECO 1. And we have indication of MECO 1. Pumps are spinning down, pressures are where they're supposed to be. And we have 4S engines on, right on time. And we should be starting our pre-MEF 2 sequence any moment now. And we have 4S engines on. We have locks pre-start. And housing temps are responding. We have ignition and full thrust. Center main engine is up and running normally. Start signature looks good. RCS system is off. And center PU's in closed loop control, everything looks good. And we have MECO 2. We have MECO 2 apparently a little early. And 4S thrusters are on. Continue a normal spin up. And we have spacecraft separation. Both brake wires indicate a satisfactory separation. And the vehicle is de-spinning as expected.
Mission success for the inaugural Atlas III, a successful flight, and we've had spacecraft separation, a beautiful flight, an absolutely fantastic mission.
We have ignition and liftoff. We have liftoff. And the vehicle has cleared the tower. And engine operating parameters look good. Pitch program is in right on time. Vehicle now operating at 92% of rated thrust. Hydraulics are up and running and look good. We have Atlas to you to closed loop control. Engine operating parameters continue to look normal. And everything continues to look good. The vehicle is now throttling down in preparation for supersonic transition. We continue to fly normally. Everything looks good. Operating parameters continue to look normal. We're on GDMTA data. Data quality looks good. Selecting the throttle up post-transonics in 15 seconds. Everything continues to look normal. And we are throttling up. Vehicle rates look nice and smooth. Throttle up is complete. Everything looks good. And we're now passing through the region maximum dynamic pressure. And rates are smoothing out as we're passing through transonics. And everything continues to look normal on the engine. Staying steady at 87% thrust. Next mark event we're looking for is firing the pyro valve to pressurize the reaction control system in 15 seconds. Engine parameters continue to look good. And we fire the power valve. Control system parameters are pressurizing.
Go ahead. Yeah, Jim, go ahead and shut the water off.
And running the next throttle segment. Engine operating normally. Everything looks good.
Okay, I confirm that the deluge is off.
Engine operating parameters continue to look marvelous. PU is showing active control. Current in our next throttle segment, the constant 5.5 G hold throttle segment. And we have boost phase chill down starting. Housing temps are responding to the flow of fuel through the Centaur engines. Everything looks good. And we're continuing to show the throttle segment. Everything looking good. We've throttled down in preparation for BECO. We have booster engine cutoff. Everything looks good there. We have stopped boost phase chill down right on time. We have stage separation. We have fuel pre-start. We have LOX pre-start. Thanks. We have ignition. And full thrust. The Centaur main engine is up and running normally. Normal operating parameters on the Centaur main engine. Everything continues to look normal on this mission. And we have fairing separation right on time. Everything is looking absolutely normal on this mission so far. And continuing to show the throttle segment, everything looking good. We've throttled down in preparation for BECO. We have booster engine cutoff. Everything looks good there. We have stopped boost phase chill down right on time. We have stage separation. We have fuel pre-start. We have LOX pre-start. Thanks. We have ignition and full thrust. The Centaur main engine is up and running normally. Normal operating parameters on the Centaur main engine. Everything continues to look normal on this mission. And we have fairing separation right on time. Everything is looking absolutely normal on this mission so far. Centaur engine parameters continue to look good.